Hi everybody, welcome to the GiSO 2025 electrical workshop where I'll be going over various different types of electrical components and how to use them. So here we have a breadboard. So as you can see here, we have a lot of different holes. So what are these holes exactly? So based off of where my mouse is, you can see that some of these holes are interlinked. But the first thing I'm going to talk about are these power rails. So we have them on both sides. But the thing is, as you can see here, we receive positive and negative ends from a battery. So you want to also connect those to the positive and negative side, power and ground, which is the negative side, that correlates from the battery onto the rail. So for example, if I put positive end to the negative end on this breadboard, then it's going to short circuit it. So the thing that is a little confusing about breadboards is that these two power rails aren't connected. So if I'm powering this half of the breadboard, it does not power anything that is connected to this half of the breadboard unless I form a connection through wires. So one way to transport power throughout your breadboard is to link your connections. This way, both sides of your breadboard can reach power. Another thing is that these rows are all connected in 5. So this means that anything that you connect here basically serves as a single spot. So as you can see, I have this LED, which is basically a component that emits light. So if I were to connect this LED, so if I were to rotate it, and connect it so that these two holes connect to the LED, it's not going to work that way because they're connected vertically. So you have to make sure that when you are placing components that they interact with different rows. So if parts are end up linked the way that I flipped over this LED, if they end up linked, it can cause the circuit to short circuit, which will result in your board not working. So in this photo here, we have a Arduino Nano. So if you've ever heard of Arduino is basically the same thing, except it's on a different shaped microcontroller, but they serve similar function. So as we can see here, we have multiple different pins, and essentially a microcontroller can be used for many different functions that we'll go over. But over here we can see we have a ground pin, another one here. We also have a 5 volts, and these will be where our power terminals connect to. And over here we have A, which stands for analog, which these are our analog pins, and then we have D over here, which stands for digital pins. So digital pins essentially read on and off values, so think of it as 0 and 1, while analog pins can read values in between that, so they read a different range of values. So think of digital pins simply turning something on and off, while think of analog pins serving a purpose like a light bulb. So digital pins in this example can turn a light bulb on and off, but analog pins can dim these lights so that they have different settings of brightness. So that is the difference between these two pins. These pins allow for the microcontroller to interact with external components like LEDs, resistors, and buttons. So one really popular component we use on breadboards are LEDs. So the way that we use LEDs is that we have an anode and a cathode, which basically represents a positive end and a negative end. So the cathode is the negative end and anode is the positive end. So obviously the positive end, you want to connect it to power, and you want to connect the negative end to ground. If you connect the cathode to power and the anode to ground, it's not going to work properly. So I'll just show right here. This is how you normally want to power it. So you have the anode connected to power and you have the cathode connected to ground. So when I try to simulate this interaction, you can see here that the current is reaching maximum, so this is not correct. When we power LEDs, we want to make sure that we use a resistor. So LEDs light up when they interfere with current. However, there's a little too much, so we're going to use a resistor to power that. So the way that we're going to fit this, remember how they work, the breadboards work in rows. If I connect it like this, I want to make sure that this cathode, because they're in the same row, these two are connected. However, this end of the resistor is not reaching any ground. So we want to delete this wire. We want to connect it this. As we can see, it's connected in this row, so we want to connect this into ground. And if we try this, we can now see that our LED is lighting up. So over here we have a push button, and we need to make sure that it is connected to one of our digital pins, and we need to also make sure that we have their terminals connected to ground and power. So the reason why we need to connect this to one of our digital pins is to make sure that when we do press our button, it is able to send back into our program whether or not this button is being clicked or not. So if it is being clicked, it'll return a value of 1, and if it is not being clicked, then it'll return a value of 0, which will let the code know whether or not it is clicked. And if it is clicked, then somewhere on your microcontroller it will signify that it is being turned on. So for this, we have a component connected to our Arduino. So this component is called an active buzzer, which generates different music notes. So usually for other components, as we can see here too, we have a negative and a positive terminal, but usually other components will have their positive and negative terminal connected to power. So as we can see here, we have our negative terminal connected to ground so that it receives some sort of power. But over here on our positive terminal, it is connected to a digital pin instead of 5 volts. So the reason that is because in order for this component to generate music notes, it has to receive code. So the way that it receives power as well as code is through this digital pin.